So this is the video for section 3.3. It's super similar to section 3.2 because now we are just talking about multiplication and division versus in 3.2 we were talking about addition and subtraction. So the big thing, the key idea here is what we want to remember is when you multiply or divide each side of an inequality by the same positive number, that's really important here, the inequality remains true. And yes, it has to be a positive number, and we'll talk about in a little bit what happens if it's not a positive number. So let's just check out an example. If I have 4 is less than 6, we know that's true, right? 4 is less than 6. Let's say I multiply each side by 2. 4 times 2 is 8, 6 times 2 is 12, 8 is less than 12, that's still a true statement. That's what this property is saying. Same thing with division. If I had 4 is less than 6, and then I divide by 2 on both sides, I get 2 is less than 3, also true. So what we want to keep in mind is if that we do this with negative numbers. Let's read this. When you multiply or divide each side of an inequality by the same negative number, this is really important. The direction of the inequality symbol must be reversed in order for it to remain true. So let's check this out. If I had negative 10 is less than negative 5, that's true. But now I'm going to multiply by negative 2 on both sides. This would say, let's test it out. This would now say 20 is less than 10. That's not true, right? We have to flip this inequality for it to be true. Same thing with division. So we have to remember, and let's jot this down if we haven't already, when multiplying or dividing by a negative, remember to flip the sign of the final answer. And by sign, I obviously mean inequality. Make that more clear. Okay, so let's check out some things to remember here. It says you solve an inequality using multiplication and division the same way you solve an equation, using multiplication and division as long as you are multiplying or dividing by a positive number. So again, this is just reiterating, remember when you multiply or divide by a negative, you have to remember to flip the sign. So let's do this, guys. Here's our first two examples. It says 4b is greater than or equal to 36. Get the b by itself, I have to divide both sides by 4. Divide by 4 on both sides, I get b is greater than or equal to 9. There's my final answer. If we want to practice graphing, I'll put 9, I'll just go 8, 9, 10. I put a closed circle on 9, and it says b is greater than or equal to 9, so I'm going all numbers greater than 9. This one, how about I rewrite it over here so we can see it a little bit better. It says n divided by negative 6 is greater than or equal to 7. So what we're going to do is I need to get this n by itself. So how we get rid of that negative 6 is I multiply both sides by negative 6. Because then these are going to cancel. I'll be just left with n. Remember, I'm multiplying both sides by a negative number. So when I go rewrite this, I'm just going to flip that sign right away. And there's my final answer. N is less than or equal to negative 42. And again, I could graph that, put negative 42 on the number line. Close dot because it's or equal to, and it's all numbers less than negative 42, so that's this way. And then this last example, it says, I'm going to rewrite it because it gets a little bit fuzzy here. It says negative 8 is less than negative 1/3 x. What I want us to note is that when we see negative 1/3 x, guys, that's the same thing as if it was negative x over 3. So now to take care of that, we're going to multiply both sides by negative 3. So I'm going to have negative 3 times negative 8, that gives me 24. I multiplied by a negative, so I've got to flip the sign, and my x is by itself. Remember, we want to have the variable first, so I'll flip everything. That's a better answer. And then we can practice graphing, 24, 25, 23. Close circle because it's or equal to, and it's going less than. So I'm going all this way. Okay? Let's check out some word problems. So it says, You have $9.60 to buy avocados for a guacamole recipe. Avocados cost $2.40 each. Write and solve an inequality that represents the number of avocados you can buy. So if we only have $9.60, guys, that means I have to spend less than or equal to $9.60. So we have to think about in terms of the context, what's it talking about? Is it less than or greater than? If that's all my money, it can't be greater than, right? And then if it's $2.40 each, I'm going to have $2.40 each because I'm going to multiply by how many avocados I get. Solve that. I'm going to divide both sides by 2.4, and then I get x has to be less than or equal to 4. That's how many avocados. It says, are there infinite solutions to the inequality in context of the scenario? No, because I can only buy 0, 1, 2, 3, or 4 avocados. I can't buy negative avocados. And just to back this up here, x is less than 4. That means to represent the number of avocados, I can buy less than or equal to 4 avocados. Okay? And then let's check out one more word problem here. It says, write and solve an inequality that represents the value of x if the area, so remember, area equals length times width of the rectangle is a minimum of 40 units. So let's just set this up. Here's my formula, area equals length times width. The area has to be a minimum, so that means it's going to be greater than, that's the smallest value, has to be greater than 40. Then when I substitute this in, I'm going to say 40 is less than or equal to length times the width. And then I'm going to plug this right in. What I know is my width, here's my length, and here's my width. Substitute it right in, divide by 4 on both sides, and I get x is going to be greater than or equal to 10. Okay, guys, that's this last section, 3.3 so far. Great job.